Welcome back, everyone. I'm John Furrier, host of theCUBE, with Dave Vellante, who's out on assignment right now, getting some action on the show floor. This is MWC live coverage 3 days, and we're bringing down all the action. As AI comes into the telecom operators, infrastructure, and carriers, and as the enterprise want to leverage the edge, a lot of new capabilities are emerging. It's a super exciting show as AI is infusing into data-centric architectures. Jeff Aarons here is the Vice President of Product and Solution Marketing at HPE.
Yeah.
Welcome to theCUBE,
Thanks,
good to see you.
Yeah, it's good to see you again.
So, I love this show, always loved MWC because I'm a networking nerd by heart, and I always said, networking is always the last area to get innovated, but now with AI factories, you're seeing the tokens, and you see NVIDIA and all the success people are doing with AI large language models, frontier models. It's inevitable the edge will have AI factories or high performance, large scale clustered systems. Yep. But networking always is the fabric that makes the connected systems work better. So you bring in the far edge, you got wireless, wireline, you've got a lot of backhaul. The telecom has always been kind of like sitting there waiting to take advantage. It's like hanging around the barber shop looking for a haircut. They missed the cloud, okay? But I think AI, they're perfectly positioned to provide the kinds of services and maintain their position. This seems to be the theme of the show.
I think so, yeah.
Agents are being discussed, but the high level direction is telecom has an opportunity to leverage their position, have an architecture that's data-centric, and monetize.
That's correct, yeah.
In new ways.
Yeah.
What's your reaction to that?
Yeah, I agree 1000%. So it's kind of funny, we have multiple businesses, right? And one is our routing infrastructure business, and they keep joking that routing is sexy again, right? It used to be plumbing, but no, now it's very strategic to adding up the value chain, and a big reason for that is AI workloads, right? They're moving everywhere now. They have to move to the edge, and for them to move to the edge, you got to get them outside of the factory and to all the locations, and so, yeah, we're right in the core of that, and it's super exciting. And
the other thing too that I think positions you guys well is that the data coming from existing models to the edge is clearly going to be an interplay. And we've talked on theCUBE, certainly with you guys before, many times, that data will move to the compute.
Yeah.
If the compute memory at the edge, that's cool, but the edge is so big it has to talk to other edge nodes.
Yeah.
So again, routing concepts come in handy.
Yeah, I think that's exactly right. So if you look at the networking bit alone, right, there's 4 areas that come into bit, right? There's scale out, scale across, scale up, and on-ramp, right? So 2 are within the data center, scale out and scale up, but scale across and edge on-ramp basically mean you got to figure out how to connect to those areas. And those are just networking, right? What you also touched on is, so how do you take all those networking components, which we like to play in, and also combine it then with the compute components, which HPE also likes to play in. So this is why we're super excited about our position right now, because it's all coming together with networking and compute and all the different areas.
Yeah, I'm super excited when you were coming up before we came on camera. I was just publishing on LinkedIn, I published on theCUBE research, the new hyper-converged report I put out, and the thesis was the edge is going to hyper-converge. We've been doing theCUBE for 17 years. We've covered hyper-converged in the data center, then it became unconverged, but then you got the super factories. But talk about the importance of this hyper-converged direction, because that's going to change the game, just like it did in the data center, storage, compute, and networking. But now you got storage, compute, networking, and AI workloads. So talk about what's different now at the edge as you look at this kind of trend towards collapsing all that capability and making it high performance.
Yeah, so I mean a couple different things. So one is we talked about performance. Now more than ever, you got to figure out how to do ultra-low latency, lossless connectivity to the edge, right? And I mean that was always important, but now I think especially to maximize the value of the GPU. The other thing I think that is often overlooked is just the operational aspect of that, right? So if you do have your compute and your network together, how do you manage that as a system, right? Instead of different disparate parts, right? In terms of provisioning, and in terms of management, in terms of troubleshooting, and even bring that into a common AI engine to troubleshoot that. So I think those are some different areas that are evolving there.
Paint the picture for the edge, because when people think about AI factories, they think about the NVIDIA systems. They're monster racks, they're they're dense, the memory's really close to the GPUs, you got all kinds of subsystems around interconnects, it's very engineered, like kind of big thing. That's not always the case at the edge. Footprints are very diverse, from very low power to some power, maybe some threshold to some higher power. But you're not going to have the ability to have a monster rack.
No,
you have to have
footprint, power, right? I mean, it's all constrained.
Compute and memory seem to be the core things, whether it's GPU or CPU or XPU.
Yeah.
Talk about that dynamic and what that means to the distributed computing.
Yeah, it's a great point. So if you look at NVIDIA first, what you just mentioned, I think one of the things that's super interesting about HP networking in NVIDIA is that prior to the acquisition, Juniper didn't do much with NVIDIA, right? But now that things are moving out to the edge and the core, we've actually established a partnership around routing, right? So how do you do that edge on-ramp? How do you do that DCI, that factory-to-factory control, which is not an area that they primarily focus on, so they are looking for routing to do like low latency, low loss infrastructure, so that's an area where the partnership comes in. And so to support that, exactly what you said, you need additional hardware and operations on our end, right? So like our MX301 is a small platform, right? You got to stick that into these edge devices, fit within the footprint, be powered, or we come out with things like our JCNR, which is our containerized router, which runs on a ProLiant server. So again, sometimes you don't even have the infrastructure or the space to even put a router in there, right? So it's got to be on your compute platform. So these are some of the things we're looking at, right? How do you bring these together? How do you make it as dense as possible, as low power as possible, and then how do you bring in the ops, right? How do you tie that together?
I'm really glad you brought up NVIDIA. I'd love you to clarify the relationship with NVIDIA to you guys and networking, because a lot of people think, oh, NVIDIA's got networking. And they do, within their systems. There's a lot of networking and LLM routing that's going on within that little system. Again, this clustered system. But that's not like classic routing. So describe why this horizontal or routing specifically, and how that relates to the benefit of NVIDIA or...
That's a great question. So it kind of comes back to what we mentioned, or what I mentioned earlier, is that the way we view it, there's 4 networking use cases for AI workloads, right? There's scale out, where switches talk to each other. There's scale up, where within the switch it talks to each other, and that's where NVIDIA Spectrum really plays, right? That's our primary market, and that's where they're primarily going out. But in addition to that, there's scale across, where the AI factories talk to each other, data centers talk to each other, which is traditional routing, big routings, very high buffers, very low loss, big iron there. And there's the edge on-ramp. How do you actually get it into the cloud, which is more of our edge routers, inference routers. And so that's where we started a partner with NVIDIA going back to our HPE Discover in December, and there's more announcements that will be coming with these guys, but again, how do you take that partnership for different use cases, whether it's AI factories, AI grid, to focus on more DRAN in those environments, but it's a nice synergy there.
It's a great comment. I asked Jensen at his GTC in DC, the recent one he had, and the next one's coming up next month, or this month. I asked him, what about AI factories at the edge and maybe metro? He said there'll be many factories. He kind of answered it, but he allowed the dots to be connected by not answering directly. He didn't say we'll have an NVIDIA factory at the edge, but he was implying was others will. So you agree that you guys see AI factories at the edge, just not the big honking.
We do, it'll be a different size, but inference in particular is moving to the edge. I mean, it's just a fact of life, right? And so you need to figure out, either it's an AI factory or some offshoot of that, how do you move it to the edge? How do you get that data there? And how do you incorporate that back into the system, and how do you manage it all as a single operational?
I mean, it's so obvious to me, distributed computing is a bunch of factories talking to each other, doing the kinds of policy that's not networking policy, but kind of the same.
Yeah.
AI workloads have all kinds of different things going on. Just bring the right model down. So networking combined with AI.
And compute,
And compute. Explain, unpack that, because I think that's what people tend to miss. It's classic networking for sure. I'm moving packets around, but there's workloads in there too that have policy. So policy is threading across.
I think you're exactly right. I mean, from an HPE standpoint, for us it's where is the AI stored? Where is the AI served? And how do you move the AI, right? So it's compute, storage, and networking all contribute to how you do that, right? And the ultimate goal, the ultimate holy grail for a provider is a common operational platform for that, right? So whether it's GreenLake or OpsRamp, like how do I pull all those things together so I have a unified view? If something goes wrong, which is it? Like why did the model fail, right? And so us being able to do that is key to what we deliver to the equation.
Jeff, I think you nailed the show in one sentence. Bringing AI to the providers is really kind of what's happening. Talk about some of the news you guys had, because you had the on-ramp. Explain some of the things that you're doing now here at the show, and how that relates to the providers and the carriers having a model architecturally and also business model?
Yeah, thanks for asking that. So there's a bunch of things that we're primarily focusing on, right? So the first is, as we talked about, is performance, right? Like we said, the telcos need performance as you move inference to the edge, as you scale between AI factories, right? And so to that end, we announced some new routers, right? Our PTX 12K in particular, 12,000, is a big honkin' router. It's probably the highest performing router on the market, right? 800 gig ports, 54 ports per line card, up to 32 line cards. So we're talking big, massive type of infrastructure. Shortly before that, we also launched the MX301, right? So that's those edge on-ramps. So we're providing the hardware to do that, which is super interesting. But on top of that, we're all about the self-driving network, right? How do you add the agentic, autonomous AI ops capabilities with that? So to date, our routing infrastructure was already tied to our Mist AI ops, so how you do things like pull in the data and add a conversational interface. And what we announced in addition to that is we also added an MCP server, so you can also work with a third-party LLM. So if you're not using us, you want to use like GPT to query your routing infrastructure, we announced that as well. And then the third thing is we've added our JCNR, our containerized router, to our ProLiant platforms, right? So it's just a validated solution that comes in and says, okay, for those smaller data centers where I can't put a router in there, let me look at HP to bring it all together under a common platform.
And that addresses the footprint, the ProLiant
Exactly
piece.
right.
So I have limited form, small little cabinet.
Exactly.
Remember the old days, the telephone closets, remember? But a lot of these footprints look like that.
They do.
Small cabinets, I got some power.
Absolutely right. You may not even be able to fit a 2RU PTX or 2RU MX, right? So you're dealing with even tighter constraints than that.
Talk about the agentic piece and how that relates to how you guys see the upgrade cycle, because we're predicting, we haven't published the numbers yet, but looking at some of the big providers, the North America alone is billions of dollars, maybe 300 billion roughly. One carrier is like close to $100 billion of refresh. Retrofitting either central offices or facilities. They have towers. They have power, they got connectivity. Maybe a small cabinet or a big cabinet, but it's not, a monster 100 gigawatt.
But even then, if you're talking about distributed cabinets, like one of the biggest examples that, Juniper and Mist and HPE always did around agentic and self-driving was the elimination of truck rolls. Right, so now more than ever, if AT&T doesn't have to ship someone out to rural Iowa or downtown Menlo Park, right? That saves them time and money if the system can self-heal or self-configure or self-optimize, right? So that's what the holy grail is for any operator, let alone a telco that has a more distributed interface.
That's a great point, Jeff, because you think about it, look at the data centers that are being built on the CapEx. It's in the news all the time. Billions of dollars being, the state's going to build a mega data center, AI factory. The skills shortage is huge. So imagine the companies that have to go out and refresh this. There's grids involved, there's all kinds of multiple operating deployment factors. What's your response to that? You guys just plug and play, go?
Yeah, I mean that's the goal, right? I mean certainly, that's where standards like MCP come into play. That's where us being able to tie in with OpsRamp and GreenLake to bring some of these systems together. Obviously, an all HP system has the ability to work a little bit better with an all HP system, but also that's why we establish partnerships with NVIDIA and other folks, right? To actually be able to come in and say, okay, these are the solutions you want to use. We're going to try to make this as easy as possible for you to operate it, configure it, and then optimize it going forward.
You mentioned earlier, like having one unified platform, the control plane at the edge, because you got the far edge, where I'm talking about spectrum and unlicensed spectrum, wireless access, both on premises and also out in the wild. It's important that those radios talk to each other and then have some backhaul, which is a factory and router and all the hardware. How does that control plane look? What's the strategy? Explain the Juniper, HPE combination now. What's the message to the providers out there that are watching and enterprises that want to get really high-end service? I
mean, I think you answered it in that, look, the control plane has to be distributed, right? You need to be able to serve the data where it makes the most sense, right? And especially if the network goes down or the back, it's got to be able to run and serve it if you can access it from a management plane standpoint. But we are seeing more and more that the management plane wants to be centralized. It needs to be unified, right? And it's not a common dashboard anymore, right? We like to say AI killed the UI star, right? It's like, it's not about a dashboard anymore, it's about the unified operations, right? How does it, something goes wrong, How am I taking all these different control points, doing event correlation and coming back and telling you it's a compute issue, or it's the server issue, or it's the workload issue, or it's a GPU issue, right? It's like, that's how you get to the root of the problem with limited IT resources, and that's where this all comes into play.
I have to ask you to kind of wrap up, because I think this is super important on everyone's mind, is HPE was looking to acquire Juniper by the end of 2023. I think the announcement was in January 2024. Mist was a home run, obviously, at Juniper, but they're known for the big iron routers, as you pointed out. So you have that legacy. I mean, it's in AI years, they used to talk about dog years with the internet. I think there's a whole nother classification. That's a lot of years have gone by. What's the new Instagram picture of HPE networking? If you had to kind of paint that picture.
Yeah, for sure. So the networking bit of it, I'll talk to first, is about the self-driving network, right? And HPE has fully embraced that, they're all in, right? They're leaning into that as a lead for a lot of the rest of the story, right? Like we said, compute needs a network providing it, a back-end infrastructure, right? As does the whole AI infrastructure. So we're seeing nothing but receptivity there. It's been a great acquisition. It's been super exciting where the networking BU now has substantive revenue, substantive profit, and substantive story with no gaps that fills a really important gap. So I was at the Mist acquisition of Juniper. I loved it, right? I saw them embrace it. We were able to convert the company from more of a telco routing play to one that's more AI driven and more across the gap. HPE, we have even more tools at our arsenal, right? It's now an even bigger full stack, even more resources, so we're super excited.
My first MWC was 2009. Juniper, HPE, I've been servicing the service providers for many, many decades. What's the biggest thing that's happening now? If you had to kind of put the headline out there for MWC26, what's the headline? What is the key thing?
I mean, I don't think I'm saying anything new. We talked about it. Look, data is moving everywhere right now, and the network is back, right? It's like, the network isn't just plumbing, the network is how you build a value-added service using an AI workload as a telco infrastructure, right? And so we're super excited. Like you, I've been in networking for 30 plus years, and you've seen it where it was like the core to, plumbing to, it's now right back in the spotlight.
And it's like, we all kind of pat ourselves on the back because we're always like, networking is the most important part. But now it is.
It really is,
I think 3 years ago, Jensen Huang said on stage at GTC, networking, 2 years ago, networking is the operating system for the AI factory.
I love that.
I'm like, well, that's networking, it's not an OS. But what he meant was the coordination between the subsystems in that factory. So at the edge, you have to have those factories networked. That's the control plane. And then the rest is just blocking and tackling networking.
It's an exciting time.
All right,
for sure.
Jeff, thanks for coming on.
I appreciate it,
Good to
John.
see you, appreciate you coming on. HPE, obviously, with the Juniper acquisition now, 3 years on the books. Finalized. As the world goes to the edge, networking is the fabric, unified control planes, observability, cloud native capabilities, distributed computing. This is the future of the telecom industry. Of course, it looks a lot like the enterprise. We love that. Thanks for watching.